we'll move on to the second important module. It's a solar radiation geometry. So in our previous class, we already discussed a brief introduction about solar radiation geometry. So it's a very much necessary to study the solar radiation geometry. Means the solar radiations or a solar rays reaches from sun to earth, okay, through some inclination. They are not directly reaches through the horizontal or vertical plane. They are reaches through some angle, and that angle it is not same throughout the day or throughout the week or throughout the month. It is changes. The whatever the rays from the sun to the earth, it reaches, and it is having some different angles because earth is rotating on its own axis as well as it is rotating around the sun, so that the angle on which the solar radiation receives is always changes and always varying. And in the first slide, in the slide you can observe that a sun, and around the sun earth is revolving, okay, and it changes the position. In the December it is a different position, in the March is a different position, in the June is different, and in the September is different. And so like this different month having a different inclination. And so in the second picture also you can observe, and this is what the summer and winter, okay. So the poles, north pole and south pole, how it is exposed to the sun completely 24 hours in a one particular day or one particular season, and in another particular season it is completely lack of sun. So this is how it changes the inclination, okay. Just a minute. Okay, so with move on to the a topic. So these are the some of the definitions or geometry we are going to go through this module, and based on these equations we are solve some problems. Here there is no derivations in the syllabus. They clearly given there is no derivations, only equations we are going to use, and all the definitions of these geometry. And based on this, we are going to solve some of the numerical problems. Okay, let us know some of the simple geometries are. First is latitude of location. Okay, it's a phi L, and a declination. It's a delta. And the next hour angle, we are going to discuss a slope and solar azimuth angle, and altitude angle, zenith angle, surface azimuth angle, solar incident angle, day length, okay, and local solar time. So these are the some important definitions we are go through, and based on this we are going to find out the it is easy to find out the time, okay. So time is not same for the you just observe. So time in India, that too particular in one location it is different, and in the time in different countries in a particular region it is different. It is again because of the same this solar geometry that we are going to discuss in this module, okay. Next come to the one by one we are going to discuss. Here first definition, it is a solar altitude angle. So it's a solar altitude angle, and it's also called as a solar altitude or altitude angle. Both are same, solar altitude angle, or simply it is called as a altitude angle, alpha. It's called as a alpha, okay. Altitude angle, it's a vertical angle. It's a vertical angle. Of course, it's a vertical angle between the projection of sun rays, between the projection of sun rays. See, you can observe in the figure attitude, okay. So it is a vertical angle between the projection of sun rays on the horizontal plane and the direction of sun rays passing through that point. Here it is earth, and this is a center of earth, and these are the directions east, west, south and north. And here there is a point that the point is called as a sun rays, okay, projection of sun rays, and that through that point it reaches the center of earth, okay. And here it is a horizontal plane, and horizontal plane actually now west, east and west it is horizontal, but because of the earth having its own inclination, so that horizontal is shifted to this, okay. Horizontal plane is shifted to this, and here this attitude angle, okay. Attitude angle is a sun rays reaches the earth center, and the difference in that angle to the horizontal plane. Horizontal plane to the projection of that sun rays. That angle, it is called alpha. We can call it as a solar angle or altitude angle. Clear? It is called as solar angle or attitude angle. So solar angle or attitude angle are it is a vertical angle. It is a vertical angle and it is a projection of sun rays. So sun rays in the a sun rays to the horizontal plane. So even the horizontal plane ಇಟ್ಟಿರ್ತೀವಿ solar rays projecting on that horizontal plane. ಅದೇನು angle ಬರುತ್ತಲ್ಲ that angle we can call it as a solar attitude angle alpha. Clear? Next important angle we can call it as a zenith angle. So zenith angle theta z, we can call it as a theta z zenith angle. It is a complementary. It's a complementary angle. Means it's a 90 minus solar attitude angle. Whatever the solar angle is there, that if you go subtract 90 degree with that solar angle, it gives the zenith angle. Okay, zenith angle is the complementary angle of sun rays attitude angle, and it is a vertical angle. Of course, it is also a vertical angle, and it is between the sun rays and the line of projection in perpendicular direction. Okay, perpendicular to the horizontal plane. Okay, so that first one angle is for the horizontal, we are going to consider the angle, and the second one we are going to consider for vertical plane. So vertical plane minus to that whatever the sun projected. Okay, so that we can consider as a solar attitude, solar azimuth angle. So solar azimuth angle, solar zenith angle. Okay, so zenith angle theta z. First is the solar attitude angle. It's a projection of sun rays to the horizontal plane. That is called alpha. Next, okay, so 90 minus 90 degree minus whatever the solar attitude angle, that gives the zenith angle. Zenith angle is the complementary angle. Okay, it is obtained by subtraction of 90 degree minus solar attitude angle. Okay, so solar rays to the vertical plane, that gives the zenith angle, or you can also define as it is an complementary angle of sun attitude angle, and it's a vertical angle between the sun rays and line perpendicular to the horizontal. Okay, so for that horizontal plane, if you draw one perpendicular line, okay, so horizontal line means it is the earth angle. Okay, earth in a horizontal position. Clear? And the sun rays are falling on the earth horizontal plane, so that angle we can call it as a solar attitude angle. And next, for that horizontal line, if you draw one perpendicular line and subtract that solar attitude, that gives the zenith angle. Okay, so zenith angle 90 minus alpha. If let us assume that alpha angle, so sun rays falling within 15 degree, let us assume that solar angle is 15 degree. Then what about the zenith angle? So 90 minus 15, it is a 75. So 75 is the zenith angle. If solar attitude angle is 80, then zenith angle become 10 degree. 90 minus 80, 10 degree. So like this, you can calculate this zenith angle or solar attitude angle. Okay. And next definition is solar azimuth angle, gamma s. It is called as a gamma s, solar azimuth angle. So it is a solar angle it is also a solar angle in a degree along the horizon. It is a degree along the horizon east or a west of north, or it is an horizontal angle, or we can also call it as it is an horizontal angle measured from north to horizontal projection of the sun rays. And this angle positive when measured from the west wise. If you measure from the west, okay, it is positive. If you measure from the east, so there are two positions because it's a horizontal. Okay, if you measure from west, it is become a positive, and if you measure from the east, it is become a negative. It is a solar azimuth angle, gamma s. It is the horizontal angle measured from north to horizontal projection. So north to horizontal projection. So this is the north and this is the west. If you measure from the west wise, this angle, it is become a positive. And if you measure from east and through this north pole, if you measure, it is become a negative. Okay. And next important definition, that is what a declination. So it is called as a delta declination. So next definition is declination delta. Okay. So this declination, it is the angular distance. A declination, it is the angular distance of sun rays north or south. You can take north or south of the equator. Okay, north or south to the equator. So this line is called as a equator line. Okay, this horizontal line is called as a equator line. Yes, you can see here. Yes, in this picture you can see. So this is the equator. You can able to see the equator line. Okay, equator, and this declination is the angular distance. It is the angular. It is the angular distance of the sun rays, north or south. You can take or north or south of an equator. So this is what the equator and declination. Okay, and it is the angle between the line extending from a center of sun to the center of earth, and the projection of the this line upon earth equatorial plane. Okay, so this is what the origin. Okay, so here the hub zero or center of the earth and center of the sun. Okay, center of the earth and the center of the sun, if you consider, it is the angle between the line extended from center of sun to the center of earth. Let us assume there is an earth. Okay, and here earth is there, and earth center and the sun center, it is not same. Okay, so earth center and sun center in horizontal direction, not in vertical. Okay, in horizontal, and it is having an some difference. It is the angular distance. Okay, either it is a above or it is below. If we consider two circle, if the two circles are concentric, means both the center of the circle is same point, then it is concentric. But here earth is also circle and sun is also circle. Let us assume that, and these having a center, earth also have a center and sun is also have a center, but they are not concentric, means the center is not on the, lies on the same horizontal. It is having a different. Okay, and it is having a different distance, and this distance, it is not same, it is changes. It is positive in a some season, and it is a negative in a some season, because earth is rotating on its own axis as well as revolving around the sun, so that this declination angle is not same, it is always changes. And this is a positive. Okay, and this is negative. So here is the positive. Okay, let us assume that the positive angle we can consider as a 23 degree 0.5. Okay, and slowly it become 0 in a one particular time, and again it slowly increases and reaches maximum positive, again 23.5, again starts slowly uh, decreasing and reaches a 0, and finally it is become a same 23.5 negative. So negative to positive, and while in a particular time or a particular day, it is become a 0. Okay, declination angle. So declination angle means it is an angular distance between the center of earth and the center of the sun, and the center of earth and center of sun, it is not constant, it is changes throughout the year. Okay, and it is 0 in September 22, in particular day September 22, this declination angle is 0, and December 22, this declination angle become minus 23.5, and it is again uh, 0 in March 22. Again in March 22 it is 0, and again it is in June 22, it is becoming positive 23.5. So in the first figure, okay, I explain. Yes, see here, it is in the September. Okay, September 22, the sun center and the earth center is become same, and the declination is 0. And next December 22, the earth center and the sun center, it is having a negative value, negative declination. Okay, negative declination, it is 23.5, and again in the March 22, it is becoming same, and it is a 0 declination, and again in the June 22, it is become positive. Okay, positive 22 or 23.5. Yes, you can see in the figure it is 23.5. Okay, and here 23.5, it's a negative and it is positive. Yes, this is the center and this is the center, this inclination. Okay, it is called declination angle. Clear? And this declination angle, delta is given by equation 23.45 sine into 360 divided by 365 into 284 plus n. N is the number of days, where n is the uh, day of the year. Means it is an June 22, or it is a July 23, or it is a January 23. So that is there is a particular day in the year. Clear? And this angle you can observe in the figure. Declination angle is positive, declination angle is negative with respect to the sun center and the earth center. So next is definition is meridian. So meridian is the imaginary line. Meridian means you already studied in your geography. So meridian is the imaginary line passing through the point or a plane on the earth from the north to south pole. From the north to south pole, there is a one imaginary line passing through the earth. That line is called meridian. So there is no physical line on the earth. Okay, so it is a imaginary line. Means we are yes, there is a line passing from north to south, so having some this much of inclination. So that line is called as a meridian line. Okay, yes, next is hour angle. So hour angle, it's omega. So hour angle, it's a very much important. So this hour angle, it is the angle through which the earth must turn to bring the meridian of a point directly in the line with the sun rays. Means I told earth is rotating on its own axis as well as to the revolving around the sun. Means on a particular location of earth exposed to the sun, it is based on the meridian line. Okay, when the earth start rotating slowly, so this meridian lines also changes in a one particular, if you take on a particular time, means in a exactly on the 12 a.m. So midnight 12 a.m. if we consider it is a zero angle. Okay, so zero angle, next slowly it start rotating. Okay, and if earth rotate 15 degree per hour, if it is rotating 15 degree per hour, so in a 1 hour it rotate 15 degree, means it changes next meridian line. Again for the next hour, means 12 to 1, yes, it changes one meridian line. Next 1 to 2, 2 to 3, 3 to 4, like this it will changes meridian lines, means slowly rotating. And for completion of 360 degree, it takes 24 hours. 24 hours, in a 24 hours, earth complete its one complete revolution. Okay, so that revolution 15 degree per hour. So it is called our angle omega. Okay, so omega is the angle, it's an angle through which earth must rotate to bring the meridian to a point directly to the line with the sun rays. So sun is a constant, sun won't rotate, only earth is rotating. So earth rotating means it changes its meridian lines with a 1 hour. So 15 degree, so total 360 degree, it's a circle. So earth is assumed as a circle. If you divide that, it's a 15 degree. Okay, for completion of 115 degree, it takes 1 hour. Okay, it will next meridian line, like this. Its meridian lines means the imaginary lines passing through the north to south. Sorry. And the hour angle omega is equivalent to 15 degree per hour. So and it is measured from the noon based on the local solar time. It's LST, a local solar time or local apparent time. That's what I told in the beginning. So time in the different countries having a different time, different locations having a different time, because this meridian, this hour angle measures when the meridian line exposed directly to the sun. So sun ಗೆ direct ಆಗಿ expose ಆಗುತ್ತಲ್ಲ, so that we can consider as a hour angle. Okay, so the time maybe in the India if it is 10 a.m. but in the America if you take the time, it may be in the night. So like this, it will changes. If you go with a Dubai or any Arab countries, the time difference may be 3 to 4 hours. If you go with any uh, US or UK, the time difference may be 10 hours or 12 hours. So this difference is just due to because of the this hour angle omega. Okay. And next important definition is a slope. Yes, in the figure you can see this is a slope. The slope or a angle made by the a plane surface with the horizontal. A slope means it's the smallest. It is the angle made by the plane surface. It's the angle made by the a plane surface with the horizontal. Always we are going to take the horizontal earth as a considered as a horizontal surface. Okay, and it is taken for to be positive for the surface sloping towards the south and negative for the surface towards the north. This slope angle, if you take the slope angle towards the north, it is a negative. If it is towards the south, it is positive. A slope means a angle between the collector surface. Let us assume that collector surface. I am going to collect the solar rays. If you want to collect the solar rays, I need a one collector. Okay, one flat plate collector, a flat surface, a small flat surface. Okay, that flat surface is placed in such a angle. Okay, that is become a slope beta. Slope is a angle between the collector surface with the horizontal plane, means on the horizontal surface. So on the earth, collectors are not going to place on the earth. Okay, it is always placed with some angle. ಇದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ ಏನಪ್ಪ ಅಂತಂದ್ರೆ you can take in your solar heater, okay, or your photovoltaic that solar cells. So solar cells or solar heater, they are not placed horizontally or not placed vertically. They are placed in a some angle. ನೋಡಿದ್ರೆ ಮನೆ ಮೇಲೆ solar heaters, the tubes or flat plate solar heaters are placed in a such a angle. Okay, so that is what they are placed, that is called as a slope, means on which the rays are collected. And that slope is measured by, so your terrace, okay, nim terrace mele they are placed water heater with some inclination. So that terrace is considered as a horizontal and that slope is a beta. Okay, so they are placed in some angle with respect to the terrace. That is what horizontal plane. So that angle is called as a slope or beta. Clear? Always it is having some inclination, maybe 15 degree, maybe 20 degree, or maybe 30 degree, because to increase the collection capacity or to increase the efficiency of that device. If it is placed horizontally, only in one particular time it will get the maximum. Or if you place only vertically, either in the morning or noon time, you will get the maximum. But if you place some inclination, so you will get maximum solar collections. That's why we are going with a slope. So next is a solar azimuth angle, gamma, a surface azimuth angle. Okay, already we discussed solar azimuth angle. So solar azimuth angle gamma s, but surface azimuth angle, it's a gamma. So angle between the normal to the collector and south direction. The angle between the normal to the collector. Yes, the slope means the collector is placed. If it is south direction, okay, then it is called surface azimuth angle gamma. So solar incident angle theta, it is an angle, solar incident angle theta. Okay, it is a it is the angle being measured between the beam of ray and the normal of plane. It's the angle measured between the a beam of ray and normal to the plane. or it is the angle between the incident beam radiation falling on the collector. So we already know that what is the beam radiation. So beam radiation means directly the whatever the rays which are passing through the so many hurdles and finally reaches the earth surface. So whatever we get, that it is called as a beam radiation. So the beam radiation falling on the collector with some inclination. Already collector are placed in the some angle, it is a slope, and again the solar beam radiation falling on that same collector within some inclination with some angle, that is called solar incident angle theta. And theta is not constant, it is changes with respect to the time. So theta is a 0 again in the noon time, that is what zenith position, and it is maybe positive, negative, okay, 10 degree, 20 degree, minus 10, minus 20, like this it will changes. Solar incident angle. So solar incident angle means it is an angle on an instant, so beam radiation falling on the collector. That angle is called as a incident angle, theta. Okay. So here sun is there. Okay, it is falling on the collector. So here you can see the alpha, theta z, azimuth angle, gamma, okay, solar azimuth angle, surface azimuth angle. And this is what we already discussed: equators, longitude, and prime meridian. So this is the earth station. Okay, so this is a collector. This is called as a collector on which the sun rays are projected. Okay, and we are going to evaluate so many angles. So these are the directions: east, west, north, south. So next important definition is a day length. So the at the time of sun, the day length means at the time of sunset, at the time of sunset or a sunrise, at the time of sunset or a sunrise, the zenith angle theta z, it is 90 degree. The zenith angle is 90 degree. Substituting this in the equation, we'll get the hour angle, okay, omega n, and this day length means at the time of sunset or a sunrise. So the day length means from the point of sunrise to the sunset, whatever the solar radiations which are falling continuously on the earth. So that is what a day length. In some time the day length may be 12 hours. In some time it is a less 10 hours. In some time it is maybe more day length. So more day length, a less day length, it is depends on the rotation and the zenith angle, okay, and the sun position. So it will decides the day length. In some day the day length, the daylight is very long, okay, sunset is take sunset maybe after 7 p.m. okay. In some days sunrise maybe 6 a.m. So this is what the it is not constant, it is changes throughout the day, sorry, day by day it changes, or throughout the month it changes. It is because of the position of sun and the rotation of the earth, okay. And this is given by the equation sigma cosine omega s, and that equation you can take minus tan phi and tan delta, or else you can take another equation td, day length, small d, which is equal to 2 omega s by 15, or else you can take 2 by 15 cos inverse minus tan phi tan delta, also you can take, okay. So by this equation you can easily calculate the day length and the local solar time or local apparent time. So this is the local apparent time, the time used for calculating. So by this equation we can going to calculate the time. So the time it is not same. I told the time is different for different location on the earth. So one location it may be 5:30, in another location it may be 4:30, in some other location it may be 2 o'clock. So like this it changes. Okay, so that we can calculate with the help of this solar time or local apparent time. So time used for calculating the solar angle in all equations. The local solar time or a local apparent time which does not coincides with a local clock. The solar time can be obtained from the standard time observed on the clock by applying two corrections. The first correction arises because of the difference in the longitude. Yes, longitude, okay, between the location and the meridian. So because of the meridian and the longitude, it will different. Okay, and the corrections as a magnitude of 4 minutes for every degree difference. And the second correction, it is called equation of time. The correction is due to the fact of earth orbit. Okay, it is because of the earth orbit, and this we can taken as a constant. But meridian and the longitude corrections, it is different, it changes because standard meridian angle is there and there is a correction angle is there, so that different and that will changes. But here there is a orbit earth orbit fact, it is same, and it is a rate of rotation at which is subject to a small corrections. Okay, and this corrections is based on the experimental observation. So throughout some experiment conducted, a series of experiment, they find that this is a standard correction. Okay, equation of corrections, and this you can given by the equation local time LST, which is equal to a standard time. Okay, a standard time plus or minus 4 into a 4 into, because that 4 minutes we already taken, it is a correction. Okay, the 4 into standard longitude. A standard longitude means whatever the longitude exposed to the sun, standard longitude minus longitude of location, that longitude of location, and plus equation of time correction. Okay, by using this equation we can easily find out the local solar time or local apparent time. Okay, so these are the important geometrical definitions, equations, okay, based on sun and earth. So by using these equations we are going to solve some problems. Here I am discussing one problem. Okay, so in the examination you may get similar problems like this. Okay, the problem is calculate a solar a time and a declination, a solar time and the declination at a location latitude. So that is a latitude they given 23 degree 15 inch in north, and longitude 77 degree 30 inch, okay, in east, and at 12:30 IST. So 12:30 standard local time on particular day, that is most important, on June 19th. So equation of correction is given by, that is what from the standard chart, equation of correction for that particular day. The chart is a minus a 1.1 minute 0.1 second. Clear? So you have to calculate the local time as well as declination. So we have the equations. Local time, just only we discussed what is the solar local time. The same equation you can use. This is the same equation. Okay, you can use. And here IST, the time is given already. That is what, 12 hours 30 seconds. 12 hours 30 seconds and minus 4, and they given standard time longitude. So standard time longitude is 77 standard longitude time. So standard longitude time from the chart, okay, you have to take from the chart on particular day. So that is a 82 degree 30 minute. Okay, 82 degree 30 minute, and on that day the longitudinal angle is 77 degree 30 minute. Okay, and plus that equation is there, but in the problem it is a minus, so minus 1 minute 01 seconds. So that is a correction. These are the two corrections. Okay, so by using these corrections, the particular time of the particular day is 12 hours 8 minute 59 seconds, but actually the time is 12 hour 30 minutes standard time. But applying all these corrections, if you apply all these corrections, then the time is 12 hour 8 minute 59 seconds. Okay, like this you have to find out the time. IST means Indian Standard Time. Okay, and declination, we have the declination equation that we already discussed in the declination definition. So delta is equal to 23.45 sine 360 by 365 into 284 plus n. So n is the number of day in that year. So if you take June 19th, in the problem they given June 19th, so June 19th is the 170th day in that year. So in that year maybe 360 day or 365 days. Okay, so in the 365 days, June 90th is become a 170th day. Okay, if you substitute that and simplify, you will get declination angle is 23.45. So on that June 19th, the declination angle is positive 23.43 degree. Okay, and it is 0. I told in a two particular days it is 0. Okay, in the September or in the March it is particularly it is 0, and it is and negative, and it is positive. Okay, and other days it slowly positive to negative, negative to positive. So on particularly June 19th, the declination angle is 23.45 degree. Clear? So like this you have to find out the local time as well as declination with given data. Okay. So in the next class we'll discuss solar radiation on tilted surface.